Hi, let's start off today with a couple of review problems just to make sure that we're, keeping up with stuff. So let's start with a quick sketch. Let's sketch y equals 1/4 cotangent 1/3 x minus pi over 5. Okay, so remember, well, I don't care. Do it however you want. For me, it's easier if I stop and think for a minute about what my cotangent looks like. So my regular cotangent looks like this. Obviously, you need to know that. You can't graph these weird ones if you don't remember what the base curve looks like. So asymptotes at 0 and pi, decreasing function. So I'm going to have a picture that looks like that. The difference is I'm not going to have my first asymptote at pi. This has a shift, so my first asymptote is now at pi over 5. My phase shift. My phase shift, or my horizontal shift, is right pi over 5, or positive pi over 5. So I know there's going to be another asymptote out here. Right in the middle, there's going to be an x-intercept, and my curve is going to decrease. I'm supposed to go through that point. Okay, so now I need to figure out where that other asymptote is. Now, I know that the period of my normal cotangent is pi. But this one has been altered by that coefficient, the coefficient on x. So that divides my period. So my period is pi divided by 1/3, or 3 pi, which means the distance from here to here is 3 pi. So if I start at 1/5 of a pi and travel 3 pi, then I will end up at 16 pi over 5, because 1/5 plus 15/5 is 16/5. This distance has to be 3 pi. This label is not 3 pi. The distance is 3 pi. Now, I need to be halfway in between 1 and 16. So I am going to average 1/5 and 16/5. And when I average, I add them and divide by 2. So that's 17/5 divided by 2, or times 1/2. So this is 17 pi over 10. Notice that there's a 1/4 out here. That 1/4 does change the curvature. So let me show you in my original. If this is the original picture, then 1/4 would simply flatten it out. Without having the original there, that's really hard to do in your picture. So I'm not sure how Mr. Knoll feels about that, but you need to just recognize this 1/4 flattens the picture. But in terms of like amplitude, cotangents don't have any. Amplitude is half the distance from the top to the bottom, and there is no top or bottom in a cotangent or a tangent or a secant or a cosecant. The only functions that actually have amplitude are sines and cosines. So I'm not saying that number has no impact. It does. It flattens the curve. But when you're drawing it, that's hard to demonstrate or hard to show. So don't worry about that. Just recognize it does impact the curvature. Of course, if it's negative, then it would turn your picture upside down, if it were negative. Okay, next review problem, or problems. Let's look at By the way, while I am doing this, we are going to be using our books today. So if you want to take a moment, get your book ready to go, you will need it later on. All right, let's do these three problems. All right, here we go. The answer to this question is going to be an angle. This is going to be an angle. We are finding the angle whose sine, I'll write it out, it literally says, find the angle whose sine is negative root 3 over 2. That's what we're doing. So we will draw a picture of a triangle in quadrant 4. Because yesterday we went over the rules. Got to know the rules. Inverse sine negative is in quadrant 4. Remember, the quadrant 4 inverse functions are inverse sine, inverse tangent, inverse cosecant. They're in quadrant 4. All the others are in quadrant 2. I know that the sine is negative root 3 over 2. That makes this a 30, 60, 90 with the 60 across from the root 3. My answer could be 300, but that's not right because the answers to a negative sign, remember, have to be between negative 90 and 0. So that answer is actually negative 60 degrees. If you say 300, you will be wrong. Now, not totally wrong, because obviously you got the angle in exactly the right spot. But your answers to the negative sign, or inverse sign of a negative number have to be between negative 90 and 90, or negative 90 and 0 for a negative. If they're positive, remember they're in quadrant 1. So these numbers positive are easy. Quadrant 1, done. All right, let's do this one. All right, so I'm going to draw my triangle in quadrant 2 because inverse cosine negative is a quadrant 2 function. I know this is negative 1 and this is root 2. So this is a 45-degree angle. But my answer is not 45. My answer is right here. Always starting at the positive x-axis. So that answer would be 135 degrees. Now, I am answering these in degrees. We could also answer them in radians if that's what the directions called for, or if that's what Mr. Knoll prefers. Now, this one's a little bit different because this one has this extra piece to it. Now, I can still draw this angle. That's a cosecant. Inverse cosecant negative is in quadrant 4. I know this is 3 and this is 2. Now, that is not a special triangle. That is not a 45 or a 60 or a 30 or anything special. I have no idea what that is. But I do know that if I use my Pythagorean theorem, this would be root 5. Because x squared plus 4 has to equal 9. A squared plus b squared equals c squared. So before I knew what that was, a squared plus b squared equals c squared. So I can figure out that's root 5. And it would be positive because I'm going to the right. Here's the origin. That's positive x, negative y. I have no idea what that angle is. But the angle isn't the answer this time. The answer is the cosine. So the cosine is adjacent over hypotenuse, or x over r, so the answer would be root 5 over 3. This is the exact answer. This can be typed into your calculator, well, all of these can. If you type these two into your calculator, you will get exactly the same thing we got. If you type this one into your calculator, you're going to get a decimal. This is the exact answer. Okay, good work. That's a little quick review. Let's now go to section 4A, and let's talk a little bit about some of these word problems. So I'm just going to pick some random ones out of here. Keep in mind that, no two problems are exactly alike usually. So you're going to have to use your problem solving skills. And I'm going to need a calculator. All right, let's start with number 6. I am on page 432. 432, number 6. It says a wire stretches from the top of a vertical pole. So here's my vertical pole, and here's the wire stretching down to the ground. So here's the wire, vertical pole. To a point on level ground 16 feet from the base of the pole. The wire makes an angle of 62 degrees with the ground. Find the height of the pole and the length of the wire. So there are two unknowns here. Let's start with find the height of the pole. When you look at this equation, it's a right triangle. Or when you look at this picture, it's a right triangle. You're going to write an equation using either sine, cosine, or tangent. So when I look at it, here's my angle. 90 is not the angle you use ever. You use the other one. So 62 is the angle I'm using. Could I figure out this angle and use it? Yes. But why would I go to that extra trouble? Just use the one you got. So the angle, with regard to this angle, this is opposite and this is adjacent. So the equation I'm going to write is tangent. Tan 62 equals x over 16. Tan 62 equals x over 16. So 16 tan 62 equals x. Please make sure your calculator is set in degree mode. That would be a disaster. And then type in 16 tan 62, and I got 30.09. And I think that's feet. Yeah. Okay, and then y. This is going to be the length of the wire. Now, we always prefer not to use a rounded off answer if possible. There may be times in the future when you need to use a rounded off answer, but not this time. We do not need to use this. We can pretend that's not here and use the 16 and say cosine 62 equals 16 over y. Cosine 62 equals adjacent over hypotenuse. I don't want to use this because I rounded it off. And if I use a rounded off number, it's going to cause error in my problem, and it's not necessary. We'll use 16. So I'll multiply by y and divide by cosine 62. Type that into my calculator. 16 divided by cosine 62. And the length of the wire is 34.08 feet. All right, number 10. A ramp leading to a freeway So here's the ramp leading to a freeway overpass, is 470 feet long and rises 32 feet. So you're getting off the interstate and you're going up to the overpass. What is the average angle of inclination of the ramp. So angle of inclination, that's like an angle of elevation right there. How steep is that ramp? How big is that angle? All right, so here we go. Taking a look at the angle, what sides do we have? Opposite and hypotenuse, so this will be a sine problem. So sine theta, or x, whatever you want to call it. Sine theta is 32 over 470. Well, we just talked about when you're looking for an angle on your calculator, you have to do your inverse function. When you are finding an angle, when the variable is an angle, you're going to have to do your inverse. So second sine 32 divided by 470, and it is about 3.9 degrees. That ramp is 3.9 degrees. All right, let's try 12, only because I want to make sure you can type this in on your calculator. Number 12. We got a building. Okay, so we got a guy standing out here looking up at the top of a building. And the point is 125 feet from the building's base. And the angle of elevation to the top of the building is 29 degrees, 48 minutes. And we want to find the height of the building. Okay, this is an easy problem. There's nothing different about it, except our angle is measured in degrees and minutes. So I'm going to assume that you've talked about that before, but we're going to make sure you know how to type it in on your calculator. So we want to find the height of the building. Here's our angle, opposite, adjacent. So I'm going to say tangent 29 degrees, 48 minutes equals x over 125. So tangent equals opposite over adjacent. So x is 125 tan 29 degrees, 48 minutes. All right, so let's get our calculators. I don't know if you've done this before or not. I hope you have, but if you haven't, we'll run through how to type this in. So we type 125 tangent 29. Now, to get the degree mark on your calculator, you press second angle. And angle is the apps button. Angle is above the apps button. So in the third row, second column, right next to the math button is the apps button. And if you press second apps, that's your angle menu. See how it says angle above it in blue or whatever color you got? So if I press second angle, the very first thing is degrees, so I'll press enter, and now the degree mark came up on my calculator. Now, 48, type 48, go back to second angle, go down 1, because option 2 is the minute, the hash mark, press that, and then enter. And you just found 125 tangent 2948 is 71.59 feet. So to get the angle mark, or excuse me, to get the degree mark, second angle, and right there it is. To get the minute mark, second angle, click down to the hash mark, and there it is. All right, let's try 16. 16 is a little bit different. Okay, so 16, they drew a nice little picture for us. And here's the scenario. There's a guy up here looking down car. And when he first sees the car, the angle of depression, okay, so that's right here, but we're going to mark it down here because these are alternate interior. So this angle right here, the first time he sees it, it's 15. So that's a 15-degree angle. But the car is moving toward him, so the next time he sees it, the angle of depression is 33, so now this is 33. Remember, alternate interior lines, alternate interior angles are congruent. So this angle and this angle are always the same. So the angle of depression is the same as the angle of elevation. Always, always, always. All right, so what happens? 100-foot building, so I know that's 100 feet. And I want to know how far the car travels. So really, this is X right here. That's what I want to know. How far does he travel? Now, there are different strategies for this problem, and as we get into the next chapter, we will have even more strategies for this problem. But right now, I'd like you to think about this for a second. Let's look at this little triangle right here, this little one, and let me call this A. I think I can find A. I think I can find A. I can say that the tangent of 33 equals 100 over A. Tangent equals opposite over adjacent. Now, A is not the answer to the question, but it might help me get the answer. So I can find it. So A tan 33 equals 100. And A is going to equal 100 over tan 33. All right, so I'm going to just hang on to that for a minute. That's this value right here. I could type it in, I guess. I prefer not to type things in and round them off till I'm all done, but I don't think it's going to hurt anything. So A is 153.9865. I'll give myself a few more decimal places. 100 divided by tan 33. Okay. Now, I cannot find X. I hope you understand that because this skinny triangle here is not right, a right triangle. So you can't do any SOHCAHTOA. However, the big triangle, the one with the 15-degree here, this big right triangle, I can do that one and find, I'll call it B, the whole base of the big right triangle. So if I do that, the tangent of 15 is 100 over B. The tangent of 15, look at the big triangle. Forget this line, forget the blue stuff. The big triangle, tangent 15 equals 100 over B. So B tan 15. And B equals 100 over tan 15. So now I have B, 100 divided by tan 15. 373.2051. So now, how do I find X? It's real easy. I just take B minus A, right? B minus A will tell me how far the car traveled. So, that number minus 153. So it traveled about 219 feet, 219.22 to be exact. Not exact, but So the moral of that story is sometimes you can't get exactly what you want. So you have to kind of find some littler pieces that will give you ultimately your answer. All right, let me see what else I picked out here. Tried to pick out ones that were a little bit interesting. Let's look at 26. Problem 26. Now remember when we do navigation, this 26 involves, well, it even says navigation, but it involves vehicles moving. So that's a directional thing. And so, and it talks about east and west and all that stuff. So we need to remember that on a compass, angles are measured a little bit differently. These are the measurements on a compass. So it's just one more thing you need to know if you don't already. You need to know that this is the way the angles on a compass are measured. The angles, directional angles, are measured. So let's see what we have going on here. Milwaukee is directly west of Grand Haven, Michigan, on opposite sides of Lake Michigan. Okay, so let's say here's Lake Michigan. And these two cities, Milwaukee is west of Grand Haven. Okay. On a foggy night, a law enforcement boat leaves from Milwaukee. Okay, so we're leaving from Milwaukee on a course of 105 degrees. All right, I'm going to get my link out of there because I'm afraid that's going to get a little confusing. So here's Milwaukee, here's Grand Haven, and they are directly east-west. So a boat is leaving Milwaukee. Here's my compass, Milwaukee, we're starting right here, on a course of 105 degrees. Now look at your compass. 105 degrees would be like this. This is 105 degrees. Remember, if we're doing navigation, we're using this setup. So 105 degrees would look like that. At the same time, as a boat leaves Grand Haven on a course of 195. So 195 would look like this. 195. And eventually, they collide. The law enforcement boat averages 23 knots and collides with the smuggling craft. So, I'm going to pretend that they're going for an hour. So this guy is 23. And the smuggling craft, how far does he go in an hour? This guy goes 23 miles in an hour. I don't know how many miles he goes in that hour. Now, could this be 46? Yes, but then this would be 2 hours worth of speed. So it's just easier to make that the speed and leave this be 23. Because that's the ratio they're in. And in trigonometry, it's the ratio that's important. Opposite over adjacent, hypotenuse over opposite, whatever it is. All right, so let's figure out what we know about this triangle. Because right now I don't know much about it. But I do know if this whole angle is 105, then doesn't this one right here have to be 15? Because that's 90 and 15, that would give me my 105, so that's 15. And over here, remember this is 195, this is 270. So wouldn't this be 75? Remember your original labels on your compass. Oh, Well, this is wonderful because that makes this 90. So we have a right angle. Now later on, kids, in the next chapter, we're not going to have right angles all the time. So we'll need some additional tools to solve our triangles. But right now, SOHCAHTOA is what we have. And luckily, that's a right angle, so I can use SOHCAHTOA. I don't care which angle you use. You could use 15 or 75. It doesn't matter. I think I'll use 15. So with regard to 15, this is opposite and adjacent. Remember, that's the hypotenuse because that's the right angle. So tan 15 equals opposite over adjacent. So 23 tan 15. So in the same time that this boat goes 23 miles, the other boat is going to go 6.16 miles per hour. Actually, it's not miles per hour. It's knots. Knots are nautical miles per hour. So knots is a speed just like mph, but it's nautical miles per hour, I guess, since we're on the water. Okay, let me see what else I've got. 29, last one. You guys are doing great. Last one. Okay, 29 says, okay, a mass on a spring oscillates back and forth and completes one cycle in 0.5 seconds. Okay, so think about the spring oscillating, right? Oscillating. And it completes one cycle in 0.5 seconds. So its period is 0.5. 1/2, 0.5. One cycle is one period. Its maximum displacement is 3 centimeters. So what that means is, if we look at the motion of the spring getting stretched and shrunk and stretched and shrunk, its maximum displacement, if this is the thing at rest, then 3 up and 3 down is all it goes. So I pretend I'm the spring at rest. As I'm stretched, I go out 3, and then when I come back, I move back 3 this way, 3 this way. So my displacement is really my amplitude. Now I need to write an equation for that. Now the way I drew it, it looks like a sine curve. But there was absolutely no reason that I couldn't have drawn it like this, and it would have been a cosine curve. So you could make either one. It doesn't matter. If I do it as a sine curve, then I'll have 3 sine something x. Now, what is the something going to be? Well, the something divides the period. So I don't know what that number is, but I know, I'll call it n temporarily, but I know that if I divide it, or excuse me, I know that if I take 2 pi and divide it by that number, I get my period. Remember, this number divides 2 pi. So if I take 2 pi, which is the normal period for the sine, and divide it, I get 1/2. So solving n equals 4 pi. So my equation is This one might actually be better. No, I guess it doesn't matter. Okay, well, that's it. Good luck with the rest of these problems. I think you'll be okay. Work hard and have a great day. Don't forget to buy your candy grams.